Okay, in this section 9-2, the conic section we're going to focus on is ellipse. So here's the definition of an ellipse. It's a set of all points in a plane whose the sum of whose distances from two distinct fixed points called foci is constant. All right. So in an ellipse, you've got two foci, a focus here and a focus here, right? And so the distance from each one of these to a point on the ellipse, d1 plus d2 is constant. It would be the same each time. And as this moves around the ellipse to different points, yes, you're getting closer to one focus, but you're moving further away from the other focus, and so it balances out to where d1 plus d2 is the same every single time. All right, d1 plus d2 is the same every single time. Okay, and so again, all of the points whose the sum of that distance is constant, that is your ellipse. All right. Now, some of the other parts of the ellipse, as we take a look here, along the major axis or the long axis, at the end of the endpoints there would be vertices. Okay, the endpoints along the minor axis or the shorter distance would be co-vertices. And of course, you've got the center of the ellipse. All right. And so, by the way, ellipse could be either a horizontal ellipse or a vertical ellipse based on which direction the major axis is turned. Okay, so keep that in mind. Here's another thing to look at as far as some relationships are concerned. When we look at this, my center is HK. Okay, I've got a point on the ellipse. And when we look at the relationship, there's some distances here that we want to keep in mind. The distance from the center of the ellipse to the focus, that is C. All right, that distance is C. The distance from the center, okay, to a vertex along the major axis, that distance is A. The distance from the center up to a co-vertex, right, that distance is B. And then so now the distance from this particular point right here, this co-vertex, over to the focus can be given as a square root of b squared plus c squared. All right, and so again, that would be the distance from this point to the focus. Okay, and there's an equation here that relates A, B, and C, and you can manipulate that equation to different forms depending on what information you're trying to find from it. We'll look at this again here in just a moment. But the main thing we want to kind of look at here now is the standard form of the equations of an ellipse. And one equation is for a horizontal ellipse. The other equation is for a vertical ellipse. All right. So it just depends on the orientation as to which one of the standard forms you would use. And here's what I want you to notice that's different about each one. If the A part is underneath the X portion, then it's going to be a horizontal ellipse. If the A part is underneath the Y portion, in the denominator of the Y expression, then it's going to be a vertical ellipse, right? Now, let's see. How do you know which one's A? A is always going to be the bigger of the two. And we'll get to looking at that here in just a moment as well. All right. Let's see. Because an A has to be the bigger of the two because the distance from the center to the vertex is always greater than the distance from the center to the co-vertex. All right. So that's the reason why. All right. And so what kind of information can we come up with from the equation and the values of A, B, and C? Well, first of all, we know the center is H comma K, right? The foci would be, if this is all if it's a horizontal now, it would be H plus or minus C comma K. The vertices would be H plus or minus A comma K, right? The co-vertices would be H comma K plus or minus B. Okay, the major axis is Y equals K, right? That's the Y component. The major axis is X equals H, the X component. And here is the main relationship that we're going to use between A, B, and C. All right. C is equal to the square root of A squared minus B squared. Now, A and B we can get from the equation. Once you have the equation, you'll have the A and the B. And then we can use this to figure out the value of C. And once we know A, B, and C, we can get the foci, we can get the vertices, right? And we can get the covertices. Okay, so that's where those numbers come from for A, B, and C. Now, if we switch it over and take a look at a vertical orientated ellipse, then the major difference is the A is under the Y instead of the X. That's the first difference. And then there's some differences as far as how you find the foci, how you find the vertices, how you find the covertices, and then the major and minor axis will switch, right? Okay, let's see. But this equation to find C is, of course, still the same. All right? So, again, the way you find these different points and axes depend upon whether it's orientated horizontally or vertically. Okay? One more definition that we want to take a look at, and that's the definition of eccentricity. Eccentricity, right? So the eccentricity of an ellipse is given by this ratio. C over A. So again, it comes back to these values, right? C and A. Okay? And just to kind of give you an idea of what the eccentricity measures, eccentricity is always between 0 and 1, right? It's always between 0 and 1, right? And the reason why is because no matter how long or short the ellipse happens to be, that the C divided by A is always going to be greater than C, right? And C is never going to be 0, or it would be a circle, right? So you're always going to have a number between 0 and 1 for the eccentricity. Now, what does it measure? Okay, when E is close to 0, it's more circular, and when E is closer to 1, it's more elliptical. Okay, so by looking at that value, if you get one that's close to 0, the closer to 0 it is, the more circular the ellipse is going to be. And then the closer that the eccentricity is to 1, then the more elliptical shape it's going to be. So that's kind of how that looks. All right. Next chart that we give you here is another chart that kind of gives you the same information. Okay, so again, you've got the standard form for the ellipse here. And so again, my two equations are here, one based on the major axis being horizontal, the other based on the major axis being vertical. And once again, you've got the same equation here for C. Take the square root of both sides and you'll come up with the C equals. And also, if the center is at the origin, then the equations take on this form, so we can take a look at that there as well. And once again, another diagram that kind of shows you the way it looks when it is the eccentricity is when the major axis is horizontal or whether the major axis is vertical. Now, what type of problems are we going to be faced with solving regarding ellipses? So here is an example that we want to look at. Okay. Now, this problem is asking us to do several things. First of all, it says find the standard form of the equation, find the center, find the vertices, find the foci, and the eccentricity of the ellipse. Okay? So we're asked to do several different things. Find the standard form of the equation, find the center, find the vertices, find the foci, and find the eccentricity of the ellipse. So based on this, we're asked to do 5 things. So the first thing that we want to do is see if we can take it and turn the equation from the general form to the standard form. All right, so we're going to turn the equation from the general form to the standard form. Okay, so how are we going to do that? Okay, so when we take a look at this, if we want to change it from this form to this form, okay, then the first thing that we can do here is we want to kind of attack the X terms, group those together, and the Y terms, group those together. And then that will be our starting point. So the first thing that we'll do here is rewrite this as 4x squared minus 8x. Okay? And then we will group the Y terms together, which is plus y squared plus 4y. And then we can go ahead and move our 8 to the other side and change it from minus to plus 8. Okay, then from there, the next thing that we can do is we're going to do two things in one step. Number one, we're going to factor out the x terms, right? And so we'll write 4. Then in a set of parentheses here, we'll go x squared minus 2x when dividing by 4. But now in the same step, we're going to do something else. Okay? We are going to go through and we're going to complete the square for this so that we can change it back into this form. And so remember the process for completing the square. We will take this b term, we will divide it by 2, and then we'll square it. So negative 2 divided by 2 is negative 1. Negative 1 squared is plus 1, so I'll add 1 here. Now I'm ready to close my parentheses. Okay. Then we'll go plus, and we'll complete the square on the y terms, which will give me y squared plus 4y. And again, I'll take the 4 divided by 2 and get 2. And then I'll square that, and that'll get me back to 4. So I'll add 4 to the end of that. Okay. Now, we're going to set this equal on the other side. I already have an 8 here. I'll go ahead and put that here. But now we've got to consider what we've done to the left-hand side of the equation. And you might say, Coach, well, I added 1 here. But don't forget, we factored this out. So really, we added 1 times 4 here, which is 4. So I'm going to have to adjust the other side by adding 4. And then when we completed the square here, we added 4. So I've got to add another 4 again to the right-hand side. So remember, keep the equation equal by adjusting both sides. So whatever you did to the left-hand side, you got to make sure you adjust the right-hand side the same way. Now, from here, take a look at what we've got. We have, on the left-hand side of the equation, a set of expressions with x and y that we have completed the square on. And the reason why we've done that is we're trying to get this equation into the standard form of an ellipse. So from here, what we can do is we can factor this, the x terms, again, and the whole reason why we completed the square is so that we can put it into this form. Okay, so when I take this and factor it now, I can call this x minus 1 squared. Double check all of your terms. Negative 1 times negative 1 is 1. Negative 1x minus another 1x is negative 2x, so it checks out there. And from here, now, we are going to add to that, and we're going to factor out the y terms that we had completed the square on. And so that's now going to be y plus 2 squared. Check your terms. 2 times 2 is 4, and then 2y plus 2y is 4y, so we're good there. Then on the other side, we're going to add those together, and that's going to give you 16. All right. Now, from here, we're still trying to get it into this standard form. And remember, look at an ellipse. The standard form of the equation, it must be set equal to 1, right? And right now, I've got it set equal to 16. And so to fix that, I'm going to divide both sides by 16. Okay, so now once that happens, we can write this. I can reduce this down now, and this will become x minus 1 close squared over, so 4 over 16, that'll reduce to 4 on the bottom. But now remember, look at your form again. You want this as a squared, right? And so what we're going to do now is we're going to, instead of writing it as 4, I'm going to write it as 2 squared, so it's easier for me to see the value of a. Plus, on this side now, I'll keep this as y plus 2 squared. And on the bottom side of this now, instead of writing 16, I'll write it as 4 squared. And then, of course, on the other side of the equation, we just have 1. And from here now, I have it in a form where I can read off the a's and the b's. Okay? And from here, I can go, so now I've got it in standard form. The next thing they ask me for is the center. Okay? The next thing that they ask me for is the center. Now, before I move on and try to get the center and the foci and the vertices and the eccentricity, I need to go and make sure that I have the values of A, B, and C so that I can come up with those things. All right, now, so off to the side, we're going to write the value of A. which we know is 4, because remember it's the bigger of the two. So A is 4, B is 2, and my C, I'm now going to have to calculate, remember, with this. C is equal to the square root of A squared minus B squared. So now that we have got it in standard form and read off the A and the B, we can now use that equation in order to find the value of C, which is going to be the square root of 4 squared minus 2 squared, and that's the square root of 16 minus 4, which is going to be the square root of 12. And further simplifying that down, the square root of 12 is 3 times 2 times 2. And a pair of 2's can come out of there, so that'll be 2 square roots of 3. All right? So my value of C is 2 square roots of 3. Okay, so now I have everything that I need to go and calculate or write in all the other things that they've asked me for, because now I have the values of A, B, and C. I've got the values of A, B, and C. Okay, so for my center is easy enough to write. It's just the H, the K. So that'd be 1, negative 2. Don't forget to switch the signs. 1, comma, negative 2. Now the next thing they asked me for is the vertices. Now remember, okay, when we go to calculate the vertices, we got to make sure that we were looking at the orientation of the ellipse. Since my A, my bigger number, is under Y, this is going to be a vertical ellipse. So when I go and try to figure out how to calculate the vertices, I need to make sure that I'm looking at the vertices for a vertical ellipse, because the A is the bigger of the two numbers there. All right, so looking for the vertices, right? So the vertices would be H, so I can write that first. So what was the H? Remember, this is my H and my K. My H was 1, right? So it's going to be 1, comma. The Y coordinate of the vertices is going to be K plus and minus A. So K plus A and K minus A. So my K was negative 2. What's my A? Okay, my A was 4. So negative 2 plus 4 is 2. So that's one vertex, right? And 1, comma, negative 2 minus 4 is the other vertex, which is negative 6. Okay, so remember your vertices are going to be right here, my K plus 4 and my K minus 4. So negative 2 plus 4 and negative 2 minus 4. So those are the vertices. And remember, what did we just find? The vertices are here, or along this axis. These are my two vertices. And if you plot those, you would see that. 1, negative 6, and 1, 2. Those would be my vertices if you plotted those. All right? The next thing they asked me for is the foci. So let's go for that. Okay, so the foci now are going to be, let's see, H is the same. So I'm going to go ahead and write that as 1, because that'll just remain exactly how it is. And it makes sense that all the x coordinates would be the same, because remember, the center, the foci, and the vertices, they're all along that same axis, right? So if it's over 1 for one of them, it would be over 1 for all of them. Does that make sense? All right? And it's the y coordinate that changes, and for the foci, it's going to be k plus c or minus c. K plus c or minus c. All right, so my k is negative 2. Now, since the value of c is 2 square roots of 3, we're not going to be able to make that an integer number, right? And so the way we can just go ahead and write that is negative 2, and then I'll just make it plus or minus 2 square roots of 3, and I'm going to leave it just like that. Okay, so there's no need to make a decimal number out of that coordinate, okay, or to even write it in twice on this case. We did it here because of the fact that they were integer numbers, and it's easier to look at as 1, 2 and 1, negative 6 than it is as 1, negative 2 plus or minus 4, right? Since we can go ahead and write those as integer coordinates. But with this one, we cannot get these to be integer coordinates because they are not. So you might as well just write that as a plus or minus, 2 square roots of 3 and leave it in this form, and that's the form it's going to be in on your quiz. All right. The only other thing that they had asked me to find that we haven't done is the eccentricity, so let's find that. All right. And remember, my eccentricity, E, is equal to C over A, right? So we'll go C, which is 2 square roots of 3, over A, which is 4, and that can actually reduce some, right, to square root of 3 over 2. Now, if we wanted to see how close that was to 1, then we'd have to make a decimal out of it, or how close it is to 0 and whatnot. Okay, so remember, as you're going through this, there's a lot to be concerned about here, right? One of the main things that we got to make sure that we understand is once we convert it back to this form, okay, this is my A and my B under here. You've got to make sure that you take whatever's there and convert it to squared form so that you can read it off, right? And then the next thing to make sure that you consider is if the bigger of these two numbers is underneath the X, then it is has a horizontal orientation. And if the bigger of the two numbers is under the Y, it has a vertical orientation. And that's going to make the difference of how you calculate the center, the foci, the vertices, the co-vertices, and whatnot. Okay, so just make sure that you're going to the correct side of the chart when you go in to calculate these other points. Okay, so that is it.